Good morning, everyone.
Morning,
This
sir.
Good morning. This session is about meteorology. Afternoon we will for carnival, but this one is for meteorology. So everything is okay. I think attendance must have been done already. Let us start. The topic for our session today, 1 hour session, is weather routing. We'll see how much we can cover. Otherwise, we'll spill over the next session. But we start weather routing. Now, this one is consisting of two types. One is called climatological weather routing. Climatological, this one. This is simply taking into account all favorable permanent and seasonal wind systems. This is not dependent on the particular current flowing, but on the permanent system of the climate. So that is one. Climatological weather routing. Advantage of, obviously weather routing is done to take advantage only for economical and more speed. That is the idea. But this one is implying advantage of favorable permanent and seasonal wind systems. Example, trade winds, monsoons, etc. Or prominent ocean currents, which is not seasonal, which is present all the year round. So this is the weather routing which takes into account permanent systems. Now, obviously, what we are looking at is using the information available to weather route the vessel for best possible results in way of speed, economy, and fuel consumption. There's a lot of emphasis nowadays being placed on SEEMP, Ship Energy Management Plan, Ship Energy Efficiency Management Plan, SEEMP. I'm sure you must have heard of it or may have used it because there's a separate addition in the SMS of all companies to include SEEMP. I will type it out in the chat box. I don't know if it is clear or not. But I'm trying to insist upon or say is this one. This is the new thing which has developed, new in the sense, latest thing which has developed for developing energy efficiency management plan. Energy efficiency means using fuel to the minimum to get the maximum output. So this is also part of the operation now. Ship Energy Efficiency Management Plan, SEEMP in short. When this came into force or this was started to be employed, please note this energy efficiency management plan talks about no problem about sailing down my head also, down my head, which was hitherto not heard. We never heard of these things, but now, of course, you can for energy conservation and less fuel consumption. You are allowed to sail down land also, provided you lighten your vessel, do not take extra ballast. So this is part of weather routing or ship's routing. Now one thing is certain, the shortest route may not be necessarily the quickest, because even when you are on longer route, the current, the climate, favorable climate can encourage more speed. You may not be the quickest in shortest route. Of course, shortest route means less nautical miles to travel, but it will not be the quickest. Quickest routes will be taking into account weather routing, advantage of forecast, synoptic weather maps, so that you avoid worst of the weather and take advantage of all the prevailing currents and climate. So, in a very concise thing, the technique primarily involves keep clear of high seas and swell, which are the main cause of speed reduction. And of course, they also pose danger to the ship for damage. So nowadays the vessels are equipped with the flexible weather maps. Nowadays means quite old now. The flexible weather maps, and then these weather maps can be interpreted and then can be used for weather routing. Most of the companies, like I would say most of them, are employing or hiring weather routing services from external authorities or external parties. WNI is one example, weather routing. So, and there are some charterers, cargo operators who require necessarily the employment of weather routing services. So they want weather routing services to be employed on the vessel when they are operating, which is good actually because it helps the ship staff to ascertain and take the best method, best possible route. But there's one line which is always added in the weather routing, which you might have seen in the EGC messages, weather routing messages. The final decision is left to the ship, whether they want to follow the weather route or not. It is left to the vessel. After taking all the consideration, the vessel and more so like the master will be one, he will decide whether to follow the weather map or not, weather routing or not. So they are the specialized meteorological services, but of course on payment. That is what creates a certain concern. Not all ship owners, not all charterers or cargo operators may like to pay for this, but because of time constraints, there are quite a few now who encourage this. So that is involving climatological weather routing. Means you take into account the characteristics of surface currents and weather prevailing in that particular season, climate, which is maybe northeast or southwest monsoons in Indian Ocean, which can result in more speed. There is one very good example here, exploitation of north-going Gulf Stream. North-going Gulf Stream. This is a very good current used. Very good current means gives a lot of impetus to speed. Gulf Stream, which is prevailing or flowing across the Atlantic Ocean towards the Florida coast. This current is very useful. It can leave you with a speed of plus 3 or 4 knots from your normal speed. So that will be factored in when you are being weather routed on that particular area. This will be factored in by the weather routing company or maybe yourself when you are doing self routing. This is going to take a factor. Obviously, when you do yourself, you will consider and consult ocean passages, ocean passages, you will consult to see how the seasonal and the currents are prevailing. That will help you to formulate your own weather routine. And of course, when you are near the coast, you might also consider sailing directions and where it is sailing directions to, to help you to devise your own weather routine. Then, as we go along, this is another method. One was climatological, and this one is synoptic weather routine. As you will remember, low line zones restrict the draft of ships, although correctly speaking they restrict freeboard, but obviously freeboard will fall back on drafts. So these zones also restrict the ships in certain ocean areas under very unfavorable seasonal weather. So this all helps. This also helps. So synoptic weather routing is used at best now, at present. Climatological is a long-term thing. Synoptic is as it is appearing now. While you are considering the available flexible weather maps that have been broadcasted to ships or you have received on board, by using a weather fax machine, then it is possible that you use synoptic weather routing. Weather maps transmitted by shore-based authorities or shore-based meteorological centers have almost 6 hours intervals. They could be 12 hours, but mostly 6 hours. And most of them are listed in the Admiralty sailing directions or rather radio signals to tell you at what time they are going to transmit. Like JMH or Japanese Meteorological Services, they transmit weather maps for 0840, 1440, 2040, etc. So you tune at that time and you can get the weather facts for that particular area, which is going to help you route your vessel. This is possible. The routing advice from meteorological office of meteorologists assured, which is basically hiring of a weather routing service on payment, of course. So it is correctly termed that these offices of these services are actually advice. They are not the deciding factors. They only transmit advice and then leave the final decision on the vessel to follow it or not. There have been issues. Sometimes after following them, you can get in trouble with storms, etc. In fact, one of the interactions I had with in a seminar was against the weather routing services, where one master called it the weather routing service as hire a storm. He listed it as a nickname hire a storm. So instead of avoiding a storm, he says weather routing is actually hire a storm. You're hiring one. May not be correct also, maybe exaggerated, but it is a fact that the decision whether to follow it on or not is left to the individual ship and master. So weather routing services can be provided, are used definitely, very common nowadays because priorities are for saving fuel, for energy efficiency, then this is employed as and taken as an integral part of vessel operation. This cost involved is taken as a cost involved. Nothing great about it. He says this is the added on cost or overhead expenses if he is hiring one, that is the ship owner. You can have these in, used for weather routing, monthly routing charts, wave chart, ice chart, information on current, prevailing wind, ice, and other sources such as NavTex. These is available. This can be used as example for weather routing. Or rather we can say these are aids to weather routing. If you want, you may note it down because this is a question which does appear sometimes. Weather routing, how it is done, and how will you get information or what publications you will consult to weather route your vessel. But this I'm talking about meteorology, not navigation, meteorology. From meteorological perspective, meteorology. So monthly routing chart. As you are aware, these are charts published for these areas, ocean areas, North Atlantic Ocean, South Atlantic Ocean, North and South Pacific Ocean, Indian Ocean. And these charts are published in 12 versions for each month. And they assist the navigator to plan a ocean passage for any time because he will pull out the chart applicable to this period of year which he is transiting. January, February, like that. So, like if today is 22nd September, he will pull out the chart for September for transiting maybe North Pacific Ocean, September. And maybe if he's a proactive navigator, he would also pull out October chart just to be very sure and also consider it. If not use it, at least consider it. Since we are coming to the end of the month, it is not a bad idea to consult both September and October. Obviously, these charts are prepared over a period of years, so they cannot be foolproof. There may be variations. What data is available on these charts, routing charts? These ones. Even the position of major ports is included here. Can you recognize why this is done? On a monthly routing chart, why should you have position of major ports? Of course, it is a map, it is a chart, but it is clearly marked with major ports. What do you think? Why it should be there necessarily? See, major ports are marked here also. Of course, they are available on your navigational chart, but they are marked here also because you can plan your passage you're using the routing chart, and you can also have contingency plans for in case you are in trouble, in case you want to seek a port of refuge because of weather, then you know where to head for. Then shipping routes, major shipping routes between major ports with distances, of course. Now this is also very nice because these are recognized shipping routes. They are not the routes which are going to be weather free or but they are the major shipping routes which have been used for quite some time. So these are recognized shipping routes. At least it gives a ship owner some kind of justification why to use that route, why he's using that route, because it is mentioned in the monthly routing chart, which is published by the hydrographic office, that this was the shipping route he was following, which was recognized as a norm. And then you will have, along with it, you will have data on wind speed, direction, and forces, and in short, wind rows. That will help you to see what best route can be followed with wind. and direction favorable, or if not favorable, at least minimum effect. It will also give some information on visibility and frequency of storms. Visibility and frequency of storms. Frequency of storms expressed on the windows itself. How frequent? Wind force of force 4, then 7, 8. How frequent are they? This will give you an idea of how frequent rough weather can be expected on that particular monthly routing chart. Ice limit is also mentioned there. Of course, temperature, air pressure is always there. Data on ocean currents, very important. And the limits of low line zones, which is to be used. This is superimposed on the monthly routing chart. The limits of the low line zone by red marks, you will get to know what are the zones to be used. And it's also very important for you because you have to meet the low line criteria at any time on the passage. Specialized ships keeping a track of weather and transmitting data is also located on these monthly routing charts, which are called the weather ships. This is one example. These are the windows from where you can gather what is the kind of weather. Suppose you're transiting like this, then you know what kind of weather and how frequent the wind forces or before force so and so is. Now this one is for North Atlantic. Similar charts you will have for South Atlantic, North Pacific, South Pacific. Nothing new because I'm very sure you have seen them, you've used them. But of course, now we are just undergoing the process of trying to see how seasonal or synoptic weather routing can be done. Like you have wind rows, you also have what is called current rows. This determines current, prevailing current. This is also like a chart. Pole line will show high consistency and broken line moderate, and this one will show low consistency. This one. Probable direction is by indication of the arrow. So again, this is depicted on the monthly moving chart, and you can use it to advantage. You're supposed to maintain this folder, the monthly moving charts. I'm very sure you're doing it. If not, then you must insist on it because then only you can plan your routing. If you are having access to this, this is also included in the Admiralty folder. the limits from where you can select the chart number which you want to use depending on your area of transit. And goes without saying, the routing charts cannot be used for navigation, but only for routing. This is the thing, North Atlantic Ocean, like this. 5124 bracket 1 is talking of routing chart January, and then it goes on. Obviously not to be memorized, but you should be only aware that this can be the configuration. This is included in your index also, in your chart folio index, right? I'm very sure you got it included in your chart folio index so that you can always pull it out by folio number. And it goes on. Wave chart. This is something different. These are charts which show isoplats, that is, line joining places of having same value of wave height in meters and their direction based on actual reports, compiled on actual reports. Wave charts. This is also used so you are aware of the chart and the places joined having the same value of wave heights in meters, their direction based on an actual reports received. And you can have wave prognosis charts. They show isoplats, which is again isoplats is a word used for line joining all places having same heights in meters if you are talking about waves predicted for a specified future time means this is a prognosis. They are prognosis charts. Future. It is extended. The wave analysis is extended to prognosis. This is how you also have the weather messages or the PGC messages or the fax messages, weather fax messages. First you have analysis and then you have prognosis. Prognosis is an extension by prediction. So just as a small example, we have a heavy lift ship, heavy lift cargo ship. This is going to use by planning avoid area of wave height that will be above the allowed limit for vessel safe passage. So this is useful. If the cargo being carried is a heavy lift cargo, then the ship is going to make use of the monthly routing chart to avoid areas where the wave height is going to exceed the safe passage or going to cause concern to the safe passage because more wave height will mean the heavy lift is under concern. There is just an example, of course. It would be a different scenario or a different ship. You are aware, you have gone through that, you are aware that a wave height is going to impact the heavy lift cargo by creating accelerating forces on the lashings. So, when you are using the routing chart, you will avoid areas which will have more wave heights. I mean, nothing extraordinary, but just as a matter of fact, to be mentioned in the answers. And of course, ice charts, very important ones. Ice prognosis, ice analysis charts. Firstly, they indicate amounts and boundaries of each type of ice packs, etc., based on actual observation. That is ice analysis chart. Then you have ice prognosis, which is prediction for a specified future time. And this could be for 12 hours or 24 hours. This will also exhibit what is called wind, current, and temperature of air and sea. Prognosis charts are, of course, made by experts who extend the analysis for a prediction for a predicted time. Definitely to be used when you are in ice prone area or ice area. Definitely to be used. And this is also broadcasted by the meteorological services. The time is there in the radio signal book, and then you can find out what time is the prognosis chart being transmitted to receive it. So ocean currents can have two different methods of moving the water. One will be the surface current. This is a result of flowing winds influencing surface water. And you can have deep ocean currents, which is a result of density differences which may be present in the ocean. So two types of currents could be possible, and both are to be used and could be used for speed advantage. But for that you need knowledge, for that you need information, which can be captured by meteorologists transmitting on weather services. Two very large currents on Earth which are used are Kuroshio, warm Kuroshio, and circumpolar current, Antarctica. They circulate around Antarctica. This one, Antarctic circumpolar current, circulates around the Antarctica, and warm Kuroshio current circulates near Japan. This can be used for no advantage. So this currents used to advantage can help you to reduction of shipping cost and fuel consumption. Fuel consumption is a very important thing because, as you are aware, this is the most expensive thing for the ship owner, the fuel consumption. So whatever he can save on fuel is money saved. And then, of course, if he's got speed with efficient fuel consumption, what he's going to do is he's going to reduce his time at sea or create faster turnarounds, which is advantageous for commerce. This is an example of surface currents along with wind. Let me see if I can zoom in. This one, the one we were talking of, the warm Kuroshio current can be used. Can be used, let us say, in on GC passage, cross Pacific can be used to advantage. Surface currents, a chart is here just for reference. Surface currents, counter equatorial, equatorial, counter equatorial, and then North Pacific. It is called drift, but actually it is a current, North Pacific current. North Atlantic current, this is very important. The Gulf Stream, this one. This is, if used, this can give a impetus to a speed for more than 3 knots. This Gulf Stream, used extensively on a passage from a port in Florida to cross Atlantic, maybe in Europe. This current is definitely used. On the other hand, please remember, if you are coming opposite and you hug the coast here, this is going to affect adversely. I would say this is also important. Not only using the current to advantage, but also avoiding to advantage. This is north coast of Brazil. The routing chart looks like this. So when you're planning a passage, this is also a very strong current, North Brazilian current, very strong current. It is used actually if you're transiting from Brazilian port to maybe US coast. This is used to advantage. Very useful book, and now of course available in soft copy or maybe on your Actis also. Sailing directions, Admiralty sailing direction, ASD. This is also used ocean passages, NP 136 ocean passages, and this is what is called about the 1 minute, 1 minute. This is for NP 136 for ocean passages. Again, a book extensively used. I don't know how far it is used now, but some time back it was a very important book in hard copy. Now, of course, it may be available for consultation directly, interface with the Actis maybe. I don't know, maybe. I'm not really aware, but it was a very important book used extensively, ocean passages. Prevailing winds are winds which blow almost permanently from a single general direction. For example, trade winds, which blow from east throughout the year. These are called prevailing winds because they blow predominantly from a single general direction. Then they are called prevailing winds. They will be available any time of the year. You can use the routing charts to find out information about the prevailing winds. And of course, ice, which is also a concern for the navigator. This information is also captured in weather maps and can be used. For advantage means to avoid the area. Now, this will vary from time to time, I mean from the season. It will vary. The presence of ice. It is not going to be present throughout the year, it will vary. Northern hemisphere, and then the extent could be like northern hemisphere can exist as south as Bohai Bay. But as far as southern hemisphere is concerned, it will only develop around Antarctica or could occur as far north as 55 degrees south latitude. So sea ice charts are also important to consider when you are transiting these areas so that you are aware of the limits. And of course, the ice limits are broadcasted, which you have to keep a watch for. We have covered the topic of ice, so you are aware of this. I mean, at least the basics you are aware of ice, sea ice, etc., development of sea ice, and then how to navigate if you are meeting or encountering sea ice. But these are charts we are talking of to avoid. No doubt, one of the best instruments aid to navigation, NavTex, narrow band drive printing, NBDP. So this is of course a service. It is a telex service rather provided by IMO, developed by IMO, provided by any coastal station, and this is broadcasting on 518 kilohertz, and it is called narrow band direct printing, which you are aware. NBTP is the technique used to print. This promulgates navigational, meteorological warnings and urgent information ships. It is a requirement by GMDSs to have this. This also provides aid to navigation as far as meteorology is concerned, because near the coast, NavTex is used to promulgate information regarding meteorology. Any abrupt changes in weather, any storm developing, you know, and it has audible alarms which tell you some important messages coming in. So this is also a very important equipment and can be used or mentioned. This is used for weather routing because you get information latest one from NavTex. So it can be mentioned as an equipment to be used for weather routing also. Already if you are on weather routing, maybe information received on NavTex can help you to alter your route. So regarding the weather routing, please remember weather routing and ship performance curves, they are interlinked. This is an in thing, it is happening nowadays extensively. Ship performance curves, by which the ship owner is ascertaining by doing weather routing, is he improving his performance curve for the vessel. But it will depend on the characteristic of the vessel, power, hull characteristics, etc. But somehow the weather routing can help to monitor what is called performance curves. Principal factors which impact the ship owner's and operator ability to achieve this is also included in what is called overall efficiency of a ship, quantified by EEDI, Energy Efficiency Design Index. The lesser the index, the more is the efficiency of the ship. EEDI, Efficiency, Energy Efficiency Design Index. Now, what has happened is fuel consumption of the vessels, ships, gives out, of course, some byproduct like carbon monoxide, or maybe, you know, that is also being restricted, if you remember, in various parts of the world. The emission, fuel consumption emission, is also being restricted, SOxes and NOxes. But not only that, efficiency can increase the turnaround time for the vessel. So both is being satisfied, or both are being met by controlling emissions, pollution, as well as the best method of speed. Now, one thing is definite, although whatever can happen, whatever changes can happen, but it is a well-known fact that fuel consumption will generally increase with the square of the vessel, of the speed. So it is directly proportional to the speed. The more the speed, the more the consumption. Now a balance has to be struck out between the speed and fuel consumption by using EEDI. So this is also carried out, analysis carried out. There are people dedicated to do this research at the logistics in the office. They come out with the best methods and draw a performance curve also. Now that will involve meteorology also, because the best curve will only come up with using all the current, wind, etc. to their favor. Now vessel's fuel consumption can be affected, of course, by speed, draft, displacement, weather, hull and propeller roughness. Propeller not smooth, it will consume more fuel, which is the reason why propeller is polished in the dry dock also. So this is used. The performance curve are drawn up by the logistics in the office of the ship owner to come to a conclusion that what is the optimum speed which can be achieved under certain weather conditions. Of course, the point will continue to understand the ship performance, which is propulsion power related to fuel consumption. When we are considering the ship performance, obviously wind, waves, current, they will form part of environment and there can be major contributors in the performance curve. Minor factors could be water temperature, density, etc. But these form the major contributors: wind, wave, and current. These are the factors of environment which have an impact on the performance curve for the vessel. Correct? We can have a look more maybe if required. If you will have some questions, we can have a look once again on it. But more or less, this is what it is all about: weather routing and performance curve. Do you have anything immediately to raise? Or we will need to end the session and discuss more if required. Okay, you can respond to the class feedback. That will take care for time being.
Hi batch, how are you? All good? Vandana control de do please.
Good morning, sir.
Morning page one. How are you? Vandana control please.
Good morning, sir.
Morning beta, morning guys. Morning. Very good morning. Thank you Vandana, thanks. Thanks Vandana, thanks. Okay guys, uh, as discussed last time, we'll continue with the watertight doors and see if we can close out or nearly close it out. So that shall basically cover one more topic for us, one more theory topic. Why is it going so slow? I don't know. Okay. Okay, we had done the watertight bulkhead the other day, and wherein we said that the purpose of watertight bulkheads is to ensure that there is containment of any primarily bilging, so that the water, if it gets into one compartment, does not pass on to adjoining spaces. Okay. In addition to that, there are other functions like provide strength. They provide protection against spread of fire, so on and so forth. Now, it was mentioned there also that ideally through a watertight bulkhead, you should not be cutting through for whatever purpose. That should be the underlying concept and principle. That if it's a watertight bulkhead, means you don't pierce through it, you don't cut through it. Well, on a ship, it's not possible. There may be requirements to cut through the watertight bulkhead. And if you have to cut for people to pass through it, then obviously the opening has to be something which can be opened or closed when required. So since you have tampered with the watertight integrity of the bulkhead by cutting through it and making an access for people to pass through, then that opening must have the provision of being closed watertight, number one. Number two, the loss of strength of the bulkhead because of cutting of the bulkhead should be compensated, duly compensated. And again, what is the test of it? Test of it is when the watertight door is closed, then the bulkhead, both in terms of its strength as well as in terms of its watertight integrity, should be similar to what it was if the bulkhead was not cut through or not pierced. So that is the ultimate test of the suitability of the measures that you take to close the water openings in the watertight bulkhead. And obviously, then what do you need? You would need the watertight doors. Now, in order to make the efficiency of watertight bulkhead, it is desirable that it remains intact, of course. In instances where it becomes necessary to provide access between the compartments on either side of the watertight bulkhead, watertight doors are fitted. Obviously, sometimes it's unavoidable. In that case, you'll have to fit the watertight door. Some examples of the places where you can come across these watertight doors are at the direct entrance of the access required between the engine room and the shaft tunnel in the cargo ship. So if you talk of cargo ship, If you have not seen it, next time when you go on board, please go to the engine room. Ask for where somewhere in the after part of the engine room, you will have this access to the shaft tunnel. And at the opening of the shaft tunnel in the engine room or towards the engine room, you shall have a watertight door out there. In passenger ships, let me just. Okay. In passenger ships, of course, you need at so many places, you'll need a minute. Why this is not going from here? Okay. Fine. Now, in passenger ships, watertight doors are more frequently fitted to allow passengers to pass between one point of the accommodation to the other. So if you want to go and see where a watertight door is fitted, if you have been on maybe ro-ro ships or passenger ships, then sometimes below the bulkhead deck or the freeboard deck, you may have an opening on the side for the pilot to come in. If it is so, then there would be a watertight means of closing that also, so that door will also be watertight door. The number of openings in the watertight bulkhead shall be kept to practically nil, but obviously if not possible, then minimum, compatible with the design and the proper working of the ship. Where a doorway is cut in a watertight bulkhead, care must be taken to maintain the strength of the bulkhead, because there will be loss of strength. Yes. There will be loss of watertight integrity. Yes, both have to be duly compensated. The opening is to be framed and reinforced if the vertical stiffeners are cut in the way of the opening. Now, where you cut for a door, suppose you cut in the way of stiffeners, the bulkhead had the stiffeners, और आप जब आपने plate काटी तो उसके साथ if you have to cut some stiffeners also, तो obviously whatever is the loss of strength, that has to be compensated. Even if it is not cutting of the stiffeners, cutting of the plate itself will lead to some compromise on the strength of the bulkhead. If the stiffener spacing, sometimes you want to avoid cutting the stiffeners, तो आप क्या करोगे, जहां डोर आना है वहां स्टिफनर की स्पेसिंग आप बढ़ा दोगे. अब आपने स्टिफनर की अगर स्पेसिंग बढ़ा दी rather than cutting it, तो obviously you will have to again compensate for that compromise on strength because of the increased spacing. Opening should be kept as small as possible, and opening in watertight bulkhead must be fitted with watertight doors. Why? Otherwise, the bulkhead no more remains watertight. If you don't fit it with the watertight doors, watertight door of approved type, then the opening is as good as being non-watertight. All such doors shall be closed prior to departure of the ship from the berth. All the watertight doors when you depart from berth, especially in shallow waters when you navigate, because there is a hazard, additional navigational hazard of running aground or making contact with something. So you would like to keep these doors, they are required, rather not like, you are required to keep these doors closed. What are the conditions in which these watertight doors must be kept closed? Now when there is restricted visibility, so basically thumb line क्या है, thumb rule क्या है, जब भी कोई ऐसा hazardous condition हो जिसमें जहाज के डैमेज होने के चांसेस बढ़ जाएं by way of either collision or contact with outside body or grounding, any of these reasons, if they could lead to a damage to the ship's hull, if there is an increased risk in those hazardous conditions, the watertight doors must be kept closed. So when there is restricted visibility, yes, they should be kept closed. In ports within the port limits of compulsory pilotage, yes, they should be kept closed. When the depth of the water is less than 3 times the draft, because you're in shallow waters, so you don't want to risk, you want to just be safe against any possible contact with the ground. In high traffic density, it should be kept closed. And any other circumstance in which the master feels that the condition is dangerous. So basically, when you feel that there is any hazardous condition in which threatens to cause a breach of ship's hull, then in those conditions, the watertight door must be kept closed. So far, so good, beta. Nothing much to learn. It's all common sense, which is basically automatically leading us to these points, right?
Yes, sir.
Good. Now, these types of watertight doors, what could be the possible types of watertight doors? Now, these watertight doors may be hinged like the doors of our houses, or they may be of sliding type. If they are sliding type, they could be sliding in the horizontal plane, called horizontally sliding watertight doors, or vertically sliding watertight doors. Now, mild steel or cast steel watertight doors fitted below the water line are either of vertical or horizontal sliding type, as swinging hinged type of door could prove impossible to close in the event of flooding and is not permitted. So that means hinge type watertight doors are not allowed to be fitted below the basically your deepest distinct water line. So uh, what I am trying to say is that when you talk about the deepest draft water line, you are not allowed to fit hinge door below that, because you know that hinge door would be obviously opening inwards. It wouldn't be opening outwards if it was on the side of the side plating. And then what would happen in case the water is gushing in? Then there is no way you can close. Therefore, in below the water line, you have to have the sliding doors, because sliding doors can slide and can operate when the water is gushing in, compared to the operation of a hinge door. So what is the requirement for fitting of hinge doors? Hinged watertight doors are only permitted above a deck at least 2 meters above the deepest subdivision load line. Deepest subdivision load line is your tropical fresh, guys. So deepest subdivision load line is your ट्रॉपिकल फ्रेश. ट्रॉपिकल फ्रेश के 2 मीटर ऊपर जो भी डेक आएगी, उस डेक के ऊपर आप हिंज्ड वाटर टाइप डोर लगा सकते हो. उससे नीचे आपको हिंज्ड वाटर टाइप डोर लगाना अलाउड नहीं है. इफ यू मेक अ ओपनिंग, द ओपनिंग हैज टू बी देन फिटेड विद स्लाइडिंग वाटर टाइट डोर. बेटा ये कैटेगराइजेशन ऑफ वाटर टाइट डोर्स जो लिखा हुआ है, ये आपके सिलेबस में मेंशन्ड है. दिस दैट्स व्हाई इट हैज बीन कैप्चर्ड ऑन द स्लाइड. When you say what are class 1 watertight doors, then hinged watertight doors are referred to as class 1 doors. Class 2 is hand operated sliding door. Vertical or horizontal doesn't make a difference. So class 2 is hand operated sliding door. And class 3 is power operated sliding doors. Of course, it goes without saying anything which can be operated with power has to have a backup of being hand operated as well. So class 3, when we say they are power operated, does not mean that only power operated. They have to have the provision for hand operation as well. So class 1 is hinge type. Class 2 are the hand operated sliding doors, and class 3 are the sliding doors operated with power or power operated sliding doors. These are the categorizations or classifications of the watertight doors as per your syllabus, beta. Now, in SOLAS, there are certain regulations. So chapter 2.1 of SOLAS, regulations 14 to 25, stipulate the requirements that have to be met by the watertight doors. So the performance of the watertight doors is to be regulated, and they are covered under SOLAS chapter 2.1, regulations 14 to regulation 25. All the power operated doors must be capable of closing simultaneously from bridge as well as ship control center in not more than 60 seconds when the ship is in the upright condition. So basically, what should be the performance standard of the watertight doors? You start operating all simultaneously Why the word simultaneous has come here? Because if you have a hydraulic system or any electric system which is trying to close, so it should not happen that when you operate multiple doors, the performance or the speed reduces because the resource is being shared by multiple doors. Therefore, even if your performance of one comes down because the second one is operating, it shall not be acceptable if it takes more than 60 seconds to close when all the doors are operated together. So all power operated doors must be capable of closing simultaneously from bridge and SCC in not more than 60 seconds when the ship is in the upright condition. That is when all the doors are operating at the same time. The door shall have an approximate uniform rate of closure under power. You do not want this closure to be jerky, fast at some times, slow at other times. The SOLAS requirement is that the door speed at which the door closes should be a uniform speed. The closure time of the door from the time the door begins to close, not from the time you gave command. The closure time of the door from the time you gave command to the time it closes completely shall be in no case less than 20 seconds. So it should not close very fast. So this minimum time ensures that it does not just close in fraction of a second and in one jerk it has just shut down. No. And at the same time, it should not take unduly long. It should close by an interval of not more than 40 seconds. So that means when you give command to close a watertight door, once it starts closing, the actual movement time for closing shall be between 20 seconds minimum to 40 seconds maximum with the ship in the upright condition. Is that clear बेटा? ऊपर का 60 सेकंड और नीचे का 20 to 40 सेकंड क्लियर है दोनों का डिफरेंस बेटा, फर्स्ट पॉइंट और थर्ड पॉइंट में?
Yes.
In case of hand operation of the door, during the power failure, the door must be closed within 90 seconds. So you should be able to demonstrate to the surveyor that you can manually close the door within 90 seconds. All watertight doors shall be capable of being operated when the ship is listed or inclined up to 15 degrees on either side and shall be fitted with the means of indication in the operating compartment showing whether they are open or closed. So they should have this provision for figuring out whether they're open or closed, number one. Number two, they should be capable of being closed with the ship inclined up to 15 degrees. The door shall be provided with an audible alarm distinct from other alarms in the area, because now we were saying that one of the places where you can have the watertight door is the access to the stern tube from engine room. Now engine room you have so many alarms obviously, so this is one more alarm. So this alarm for the watertight door should be distinct from other alarms so that once it sounds you know that it's the watertight door alarm. So shall be provided with an audible alarm distinct from other alarms in the area, which will sound for at least 5 seconds, but not more than 10 seconds before the door begins to move, not from the time when you give command. No. Once you give command for closure, remote command also, or local command, whatever, once you give command, the door shall start moving, and whenever the door starts moving, before it starts moving for at least 5 seconds and maximum 10 seconds, the audible alarm must sound and then only the door should start moving. Once it starts moving, it should close within 20 to 40 seconds if it is a single door operation. And we saw if it's all the doors are being put closed at the same time, the maximum permitted time is 60 seconds. So, but no more than 10 seconds before the door begins to move whenever the door is closed remotely by power and continue sounding until the door is completely closed. So that means कब शुरू हुआ? Maximum 10 seconds before it starts moving. Minimum 5 seconds before it starts moving. So alarm starts then. And then it continues ringing, 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 ringing till the door is finally closed. So that means while the door is moving, this alarm shall continue sounding, and it shall also sound maximum 10 seconds before closure. That means अब ये नहीं होता कि एक मिनट पहले why they are saying not more than 10 seconds before it starts moving is because अगर वो टाइम को रेगुलेट नहीं करेंगे, so there'll be some adventurous people who would say now the door is not moving, only the alarm is sounding, let me go inside and do something. They want to make it very clear that you do not have too much of time. It's at the most 10 seconds. Otherwise, you can count 5 seconds. So that means if you are on the other side of the door, which may not be safe, you should immediately get onto the other side. If you are already on the safer side, please do not venture onto the dangerous side. And it is also that since these are power operated doors, so that there are no obstructions. One is, yes, it has a fear of body injury if somebody is trapped when the door is closing. Number two, even if the person is not trapped, if there is something lying there that will come in the way of door closing effectively. So basically you should also have a look if you're around, have a look that that place is clear. Of course, that in any case you're supposed to keep it clear, but if you're around, also have another glance at it that the door can, so that the door can effectively shut down. The power control and indicators shall be operable in the event of main power failure as required by SOLAS. That means there has to be second source of powering it also. In passenger areas and areas where the ambient noise exceeds 85 decibels, the audible alarm shall be supplemented by an intermittent visual signal at the door. So जहाँ पे noise ज़्यादा है, audible alarm तो वहाँ होगा, लेकिन since there is a risk of audible alarm not being heard because of the noise in the surrounding, so the audible alarm needs to be supplemented, not replaced, supplemented by an intermittent visual signal at the door. Watertight doors shall remain closed when the craft is at sea, except that they may be opened for access. A notice shall be attached to each door to that effect that it is not to be left open. बेटा ये जो हमने 16 के रेगुलेशंस किए हैं अभी, ये काफी बार आपके एग्जाम में आया है, काफी बार एग्जाम में आया है. व्हाट आर द रिक्वायरमेंट्स ऑफ वाटर टाइट power operated watertight doors? So basically ये वाले जो हमने regulations किए हैं, they are the answer to that question, and if you go through past papers you will find this question having repeated multiple times, क्योंकि they want to test whether you know the SOLAS regulations about the operation of the watertight doors or not. So this is the watertight door requirement, and this question has repeated, as I tell, I'm again repeating, has been asked on more than one occasion. So many a times this question has been asked. Now we come to construction of these doors. Watertight hinge door. Let me have the laser also activated. Okay. Now, in approved positions in the upper tween deck, well above the waterline, hinge water doors are permitted. We just saw कि जो आपके deepest subdivision line load line है, उसके minimum 2 मीटर ऊपर जो first deck होगी, उस deck के ऊपर ही you can have the hinged watertight doors, nothing below that. So therefore, these are only in the upper parts of the vessel. These may be similar to weathertight doors fitted in superstructure but are to have gunmetal pins and hinges. ये जो hinge type watertight doors हैं बेटा, इनकी कंस्ट्रक्शन बिल्कुल वही होती है जो आप सुपर स्ट्रक्चर से निकलते टाइम आपका वाटर टाइट डोर होता है जिसमें डॉग्स लगे होते हैं। ओनली थिंग इज उनकी उनकी जो पिन वगैरह होती हैं या जो उनकी स्ट्रेंथ होती है या जो उनके अरेंजमेंट है दैट इज मेक्स देम ओनली वेदर टाइट। इनकी जो पिन वगैरह हैं वो गन मेटल की होती हैं। हिंजेस जो हैं गन मेटल के होते हैं ताकि उनमें रस्ट वगैरह ना लग सके। एंड दीज आर बेसिकली tested to be watertight. So the construction part of it is exactly identical to the weather-tight doors. And weather-tight doors you have all seen. I'm sure you can correlate to this diagram. Yes or no, beta? On the right hand side, you have a picture of a hinged watertight door. Can you see this picture where my pointer is moving, beta?
Yes, sir.
इसमें इन्होंने जो व्हील
Yes,
दिया
sir.
है, ये जो व्हील दिया है दोनों तरफ से, दिस हैज टू बी ऑपरेट, यू कैन ऑपरेट फ्रॉम बोथ साइड्स। एंड ये जो व्हील है बेटा, दिस विल मूव ऑल द क्लैंप्स साइमल्टेनियसली इन वन गो। हम लोग क्या करते हैं, यहाँ जो 6 7 8 डॉग्स होते हैं, क्लिप्स होते हैं, उनको एक एक करके बंद करते हैं। यहाँ आपने इसको घुमा दिया तो सारे के सारे क्लैंप्स जो हैं वो एक साथ के सारे साथ दे मूव। बाकी यू कैन सी इन दिस, ये जो स्टिफनर्स हैं ये मजबूत है, हो सकता है प्लेटिंग मोटी हो। रेस्ट इज चैनल है, चैनल के अंदर रबर पैकिंग है। दिस इज एग्जैक्टली द सेम कंस्ट्रक्शन as you have the construction of the weather-tight door, and that weather-tight door looks like, though we'll draw it as a watertight door, but I'm sure you'll remember that this is how your weather-tight doors look, right बेटा? लेफ्ट साइड में जो है इसमें क्या है, ये जिस पे कर्सर चल रहा है बाहर की बोर्ड लाइन है, ये जो ये इसका बाहर का एज है, ठीक है, बाहर का एज है। उसके अंदर ये जो लाइनें हैं, ये लाइन हो गई, ये लाइन हो गई, ये जो वी बना है, इन्वर्टेड वी बना है, इधर वी बना है, ये जो सारे के सारे हैं बेटा, ये आपके अंदर में इसके स्टिफनर्स हैं, दे प्रोवाइड स्ट्रेंथ टू द प्लेट ऑफ द डोर। ओके, ये जो साइड में दो ब्रोकन लाइंस चल रही हैं, ये चैनल है जिसके अंदर आपके रबर गैस्केट लगी हुई है। ये जो है ये चैनल है जिसके अंदर रबर गैस्केट लगी हुई है, ठीक है। ये जहाँ क्लिप लिखा हुआ है, ये जिनको हम जहाज पे डॉग्स बोलते हैं, ये दीज आर योर क्लिप्स। Okay, so this is obviously the handle. So this is the construction of a watertight hinge door, which you are all very familiar with. There is nothing much to explain. ये वाटर टाइटनेस कैसे आएगी, वेदर टाइटनेस भी ऐसी आएगी। अगर कल को आता वेदर टाइट बनाओ तो यही डायग्राम बनेगी। ओनली थिंग इज यूल कीप यूजिंग द वर्ड वेदर टाइट टाइम एंड अगेन। इसमें है क्या बेटा, ये देखिए, इसके दो दो डायग्राम इन्होंने बना रखे हैं यहाँ पर। ये जो है, ये जो चीज है, दिस इज द रबर गैस्केट, ये वाला, ये वाला, दिस इज द गैस्केट। ओके, ये गैस्केट की चैनल हो गई, ठीक है। ये डोर की प्लेटिंग है, ये डोर का आउटर एज है और ये डोर की प्लेटिंग है जिस पे मेरा ये कर्सर चला, ये डोर की प्लेटिंग है, ठीक है, ये वाली प्लेटिंग, ठीक है। ये एज के बाद ये यहाँ पर इसके डॉग का स्विवल करने का अरेंजमेंट आ गया। ये जो चीज है बेटा, ये आपका जो डोर फ्रेम होता है, बल्क हेड में जो आपने काटा है, बल्क हेड में जो काटा है, ये तो आपने ये बल्क हेड है, जो बल्क हेड काटा है, ये बल्क हेड पर आप एक अक्रॉस प्लेट लगाओगे। इससे दो पर्पस होते हैं, एक तो ये कंप्रेशन बार की तरह भी एक्ट करेगी टू कंप्रेस दिस, एंड ऑल्सो इट एक्ट्स लाइक अ स्ट्रिंजर। नो, वी डोंट कॉल इट स्ट्रिंजर, बट जैसे स्ट्रिंजर प्लेट लगाते हैं, सो दिस एड्स कंपनसेट फॉर लॉस ऑफ स्ट्रेंथ ऑफ द बल्क हेड बिकॉज ऑफ द कटिंग। ओके, और ये इसके अगेंस्ट आप बंद करोगे, ये डॉग इस पे जाके प्रेस हो जाएगा, यहाँ वेज टाइप स्ट्रक्चर होती है, एंड दैट विल पुट प्रेशर ऑन दिस rubber packing, that will come and press on it, and that will make the thing watertight. यहाँ पर ये देखो, वही चीज यहाँ पर है आपकी, सेम चीज, thing is being shown out in this diagram. So this is the hinge type watertight door. बेटा ये मेरे ख्याल से I don't remember seeing it in the paper, but when I say I don't remember, I'm not implying to leave it. I don't mean that it'll never be asked. So you need to be basically practicing this as well. Now we come to the power operated sliding doors. Vertical sliding doors may be closed by vertical screw thread, which is turned on a shaft. In these the doors move up and down. Vertical doors जो हैं, obviously vertical sliding doors would move up and down. You can see this one. It's a very simple arrangement. ये देखिए, ये जो है जहां, ये तो इसकी गाइड चैनल्स हैं डोर की, ये वाली जो है जिसपे मेरा कर्सर चला, मैं क्यों कर्सर चला रहा हूं, ताकि तुम्हें ड्रॉ करने में आसानी हो जाए बेटा। ये जो है ये इसका एक तरह से डोर फ्रेम या गाइड चैनल बोल लीजिए। ये जो इतना है ये डोर है बेटा, ये इतना, दिस पार्ट इज द डोर, दिस पार्ट इज द डोर। और इस डोर के साथ ये आपका स्क्रू वॉर्म अरेंजमेंट है, इसके साथ ये इस इन थ्रेड्स के साथ ये गियर अरेंजमेंट है आपका। जब आप इस हैंडल को घुमाओगे तो ये जो आपके ये वाला पोर्शन है, दिस विल मूव अप एंड डाउन। इसके ऊपर ये जो स्लीव है ना, जो द स्लीव इज कनेक्टेड टू द डोर। So basically what will happen is, now as you rotate it, this will keep shifting the door up. ये मत सोचना कि ये डोर के पीछे एक तरफ है, this full thing is behind the door also. So on this the door will shift up and down as we rotate this one. So जब ये डोर ऊपर चला जाएगा तो नीचे खुल जाएगा, this will be the place which will be through which the access will be opened, and when the door comes down the door shuts. So ये इसी को जब तुम साइड से देखोगे तो ये इसका ये व्हील है, इस साइड से देखोगे तो ठीक है, ये इसकी ये साइड से जो ये चैनल्स हैं वो दिखाई दे रही हैं, और ये आपको डोर की जो ये अरेंजमेंट है ये साइड से इसकी व्यू है। सो बेसिकली यू कैन ड्रॉ दिस वन व्यू इफ देयर इज अ रिक्वायरमेंट ऑफ वर्टिकल स्लाइडिंग डोर्स। अब बेटा इसी को अगर हम पावर कर दें हाइड्रोलिकली या इलेक्ट्रिकल, क्या पावर करना क्या होता है, पावर करना होता है इसको रोटेट करने को हमने पावर करना है, इंस्टेड ऑफ रोटेटिंग मैनुअली वी वांट टू पावर इट। वंस यू मेक पावर इट देन दिस विल बिकम पावर ऑपरेटेड वर्टिकली स्लाइडिंग डोर। ये डायग्राम भी पेपर में रिलेटिवली कम बार आई है, और इसीलिए बच्चों की टेंडेंसी होती है इसको छोड़ने की। बट अगेन I would say please don't leave it. If you systematically practice, it's only few lines which are to be drawn, and then you will be able to basically run through it. Then you have the horizontal sliding door. They are the most commonly fitted doors on ships, most commonly fitted doors. And these may have a vertical shaft extending above the bulkhead deck. Of course, remote location se operate kar. This can also be a power driven by electric motor and worm gear. The vertical shaft working through the bevel wheels and horizontal screwed shafts turning in bronze nuts on the door. ये देखो अभी इसको देख लेते हैं डायग्राम में, ये आ जाओ यहाँ आ जाओ। पहली बात तो ये पिक्चर है, this is not what you will practice to draw. This is hydraulically operated. You can see these hydraulic lines going on both the sides of the shaft. So when the hydraulic oil is allowed in one direction, ये shaft जो है this will move, extend and come in, telescopic shaft है ये. So as the shaft opens up, this door will slide in this channel here, and obviously the door would open. When you have the hydraulic oil flowing in the opposite direction, the shaft will be retracted and the door will close. I'm sure this picture is clear to you as far as sliding watertight door is clear before we see the diagram which has to be drawn, right, guys?
Yes, sir.
Okay, now we come to the diagram which is most oftenly drawn by people because this also looks neat, clean. So अगर हमारा ये आता है draw a power operated sliding door and they are silent on vertical or horizontal, then obviously the choice is with you. And my recommendation would be draw the horizontally sliding door, because see this diagram, compare it with the vertical sliding one. Usme hardly any labeling. It's not such a appealing diagram. This diagram is definitely more appealing than the other one. ये बड़ी सिंपल सी डायग्राम है बेटा, अगर इसको तुम सिस्टमेटिकली ढंग से देखोगे तो ये नहीं कि कहीं से भी बनाना शुरू कर देना, नहीं, आपको इसको बड़े सिस्टमेटिक ढंग से बनाना है और उसके हिसाब से आपने इसको करना है। ये पूरा का पूरा डोर का फ्रेम है जिसमें डोर ओपन और क्लोज होगा। दिस इज द फुल फ्रेमवर्क इन विच इट विल बेसिकली बी स्लाइडिंग। ओके, ये जो इतना पार्ट है दिस इज द डोर बेटे, जिसके ऊपर ये जो लाइन है ये स्टिफनर्स हैं डोर के। सो दीज आर द स्टिफनर्स, ठीक है। यू कैन सी इन दिस डायग्राम ऑल्सो, कैन यू सी दीज स्टिफनर्स गाइज? ये वाले, राइट?
यस सर।
और ये जो फ्रेम मैं बता रहा था वो ये था बेटा, ये जो फ्रेम जो नीचे में यहाँ जहाँ मेरा कर्सर चल रहा है ये वाली चीज, और ये ऊपर में ये वाली चीज, और ये आगे से ऑफ कोर्स आगे में ये ऐसे बंद हो जाएगा। तो ये इस टाइप का सी टाइप का पूरा आपका एक फ्रेमवर्क बन जाएगा, विच यू कैन सी इन दिस डायग्राम। ये वाला पूरा का पूरा आपका एक सी टाइप का फ्रेमवर्क बन जाएगा, जिसके ऊपर ये डोर आपका मूव करेगा। ये डोर के रोलर्स हैं जिसपे ये डोर इस पे चलेगा। ओके, अब इस डोर के अंदर ये आपका एक स्क्रू शाफ्ट है अंदर में, ठीक है, और यहां पर इसका डोर का ब्रॉन्ज नट लगा हुआ है, ये वाला डोर का ब्रॉन्ज नट, राइट? जब आप इसको घुमाओगे, अब थोड़ी देर के लिए इसको भूल जाओ, सपोज यहाँ हैंडल लगा होता, ठीक है, और ये चीज बीच में लगा देता, मैं सिर्फ एक होती, इफ इट वाज ओनली वन इन द सेंटर एंड ये चीज बीच में होती, तो मैं जब इसको घुमाऊंगा यहां से तो क्या होगा, ये ब्रॉन्ज नट इज पार्ट ऑफ द डोर, इज फिटेड टू द डोर। The as you rotate this on this screw shaft, this door will move either this side or that side. Yes or no, beta? Can you visualize if this shaft is rotated, whichever way we rotate, that will make the door move? Yes or no? Yes, beta. Correct. Okay.
Yes sir.
Yeah. So now to make sure that this door moves uniformly, instead of one, you have two such arrangements. And obviously what it involves, if you have two such arrangements, then they should simultaneously be operating. नहीं तो टेढ़ा हो जाएगा डोर, अगर एक ज्यादा चल गया, एक तरफ से ज्यादा चला, एक तरफ से कम चला, तो the door will be crossed and it will get stuck. So you see what has happened when you have these two screw shafts and two screws which are operating, then they need to be rotated at the same time. So that means the driving mechanism of both should be the same, so that they both rotate at the same speed together, so that the door moves horizontally without getting crossed. अब इसको बेटा इन्होंने क्या किया है, अब थोड़ी देर ऊपर वाले को भूल जाओ, इन्होंने क्या कि इसको इकट्ठा चलाने के लिए, इंस्टेड ऑफ टू पीपल ऑपरेटिंग, वन रोटेटिंग दिस वन, वन रोटेटिंग दिस वन, यहां पर ये मिलर व्हील्स के साथ, गिरारियों के साथ, मिलर व्हील्स और गिरारी जिसको आप गिरारी कहते हो ऑन लैंड, गिरारियों के साथ इसको कनेक्ट कर दिया है यहां तक। अब इस तरफ इतना देखो, यहां तक, इससे ऊपर मत देखो, अभी यहां तक देखो। एक गिरारी ये शाफ्ट लिया, एक हमने वो शाफ्ट लिया, इसके ऊपर एक गिरारी वेल्ड कर दी जो इसके अंदर लॉक हो गई, उसी की दूसरी गिरारी यहाँ वेल्ड कर दी जो इस पे लॉक हो गई। अब इसके बीच में हमने एक व्हील दे दिया। अब जब मैं व्हील को रोटेट करूंगा तो ये शाफ्ट रोटेट होगा, शाफ्ट रोटेट होगा तो दोनों गिरारियां रोटेट होंगी, ये दोनों गिरारियां रोटेट होंगी तो ये वाली गिरारी रोटेट होंगी, which are connected to the screw. So as this rotates, the screw will rotate and that will make the door move in the direction to based on the direction of rotation. Correct बेटा, यहाँ तक क्लियर हो गया?
Yes sir, clear है।
अब ये जो हैंड व्हील है, या ये जो हैंड व्हील है बेटा, दिस इज फॉर द लोकल ऑपरेशन। आप जब वहां डोर के पास खड़े होगे, सो दिस इज मैनुअल provision for closing the door when you are close to the door. So local manual, if you want to locally operate and manually, then here it is. If this rotation of this shaft is powered, then it becomes powered sliding door, horizontal मतलब powered sliding door it will become. So उसके लिए क्या किया इसने, यहां पर ये जो मैंने हाथ से घुमा रहा था वो तो प्रोविजन नहीं गया, उसके अलावा इसको ऊपर ले जाके हमने इसको इलेक्ट्रिक मोटर से कनेक्ट कर दिया। अब क्या होगा, जब मोटर घूमेगी तो शाफ्ट घूमेगा, रेस्ट एवरीथिंग रिमेन्स द सेम। इसी को कल को मोटर ना चले और मैं लोकली ना आ पाऊं सपोज, एंड शिप हैज रन अग्राउंड और समथिंग, सो इसी शाफ्ट को हम ऊपर एक्सटेंड करके डेक पे ले गए और वहां हमने एक व्हील लगा दिया। जैसे कुछ टैंकर्स में आपने देखा होगा कि आपके मैनुअल व्हील्स होते हैं, सो विच हैव द एक्सटेंडेड स्पिंडल, तो आप ऊपर से ऑपरेट कर सकते हो। इसी तरह से ये इसका एक्सटेंडेड स्पिंडल आप ऊपर ले आए, तो अब ये सारा का सारा आपका क्या हो गया, ये जो मोटर है सोलेनॉइड और वायरिंग के थ्रू इट कैन बी ऑपरेटेड रिमोटली, वहां से आप इसको ऑन ऑफ कर, मतलब इसको यू कैन बेसिकली एनर्जाइज द मोटर in both the directions. This motor will rotate in both the directions depending on the direction of the current, because you have to open and close the door. So if you can operate it from the bridge, you can operate it from the ship control station SCC. Okay, you can close it manually from above the deck, you can close it manually from here. There will also be a local control. There'll be a local control somewhere here in close to this door itself, from where the motor can also be operated locally. So that means the local operation of the motor can be from the bridge, from the SCC, or locally. Motor can be manually closed from above the deck and as well as locally. So this becomes electric powered sliding door, and if you want to be more specific, electric powered horizontally sliding door. Correct beta?
Okay, sir.
अब इसी को, ये जो शाफ्ट की मूवमेंट थी, राइट, और ये जो हमारा अरेंजमेंट था, स्क्रू वाज मैकेनिकल, इसकी जगह, इस स्क्रू शाफ्ट की जगह, इसी डोर में, इफ आई रिप्लेस दिस विद द हाइड्रोलिक शाफ्ट पिस्टन, हाइड्रोलिक पिस्टन से इसको रिप्लेस कर दें, इसको और इसको हाइड्रोलिक पिस्टन से रिप्लेस कर दें, ये देखो, और वी कैन हैव ओनली वन पिस्टन आल्सो. सो ये देखिए, these two screws have now been replaced by a hydraulic piston. ये राइट में जो डायग्राम है, और हाइड्रोलिक पिस्टन में आपने हाइड्रोलिक लाइन इसके इस साइड भी दे दी एक, और एक दूसरे साइड पे दे दी. नाउ डिपेंडिंग ऑन विच वे आर यू पंपिंग द ऑयल, द पिस्टन शैल ऑपरेट. नाउ एज द पिस्टन ओपन्स एंड क्लोजेस, द डोर विल स्लाइड. तो आप इसको लेकर चले गए, डेक पे भी हैंड पंप है, यहाँ पर, यहाँ व्हील था, यहाँ आपका हाइड्रोलिक, जिन्होंने टैंकर्स में जैक, what we call as hydraulic jack to close the valves manually. So you have the hand pump arrangement here on top, right? You have the local hand pump arrangement here to close, because you don't have the wheels. Wheels are replaced by these hand pump operated locally as well as remotely. And you have this hydraulically operated horizontally sliding door. ये दोनों डायग्राम सेम है, ये हाइड्रोलिकली ऑपरेटेड है, ये इलेक्ट्रिकली ऑपरेटेड है. इसमें आपने बेसिकली, बिकॉज योर क्या नाम है, सिस्टम इज हाइड्रोलिक, so instead of the screw shaft you have the hydraulic piston or hydraulic cylinder here which has come, and that piston will make the door move up. तो ये जो बाकी की डायग्राम है, ये जो बाकी की जो छोटी डायग्राम है, इट इज द सेम थिंग, एक्सेप्ट इसने एक ही शाफ्ट दिखाया हुआ है. तो आप एक यहाँ पर हाइड्रोलिक सिलेंडर बना दीजिए इसकी जगह, ये इसको हटा दीजिए. उसके बाद ये बेटा मिलर व्हील्स हट जाएंगे, ये मिलर व्हील्स आर नॉट रिक्वायर्ड. व्हाई? बिकॉज शाफ्ट में जो लाइनें आएंगी वो हाइड्रोलिक ऑयल की लाइनें आएंगी, एंड दैट विल बिकम हाइड्रोलिकली ऑपरेटेड हॉरिजॉन्टली स्लाइडिंग डोर. आर द टू डायग्राम्स क्लियर बेटा? Is it clear beta?
Yes sir.
Yes, sir, clear.
Okay. So बेटा ये दो डायग्राम जो हैं, they are again part of your question number 4. ये क्वेश्चन नंबर 4 में ये डायग्राम तो बहुत बार आती है. मतलब they don't ask horizontally, sometimes they may say horizontally sliding door, but otherwise a power operated sliding door या sliding door भी खाली बोल दे, sliding watertight door भी, में उसमें भी ये बनाओ, because this will fetch you the maximum marks, because especially the electrical one, because there are so many parts to label, and obviously it is more appealing for the evaluator to give you marks, unless somebody says draw the hydraulically operated, or somebody says draw the vertically operated, or somebody says hinged watertight door, then of course you'll have to be guided by the question. Now we have these on the ships, this drill for closing the watertight doors. Drills for the operation of watertight doors shall take place every week. Also, the door should be checked before leaving the port. All watertight doors, both hinged and power operated, should be operated daily during the rounds. The door should be able to operate from both local and remote places, that is bridge and the ship control center, as well as local operation. We saw there was a wheel and also a hand pump in case of hydraulically operated one. If the door is operated from remote location, there should be an audio visual alarm during the closing, which we saw that this alarm shall start sounding maximum 10 seconds before the door starts moving, minimum 5 seconds before the door starts moving, and thereafter it shall continue sounding till the door is fully shut. There should be indication of both open and close on the remote place of the operation. That also we saw in the SOLAS requirements of chapter 2.1. Now, test of watertight doors. Every watertight door should be tested by subjecting the door and its frame. Why? Because the frame is an integral part of the door, to a hydraulic pressure equivalent to the head of water measured from the bottom of the door to the margin line in way of the bulkhead to which the door is fitted. Obviously, would जैसे bulkhead की testing कर रहे थे, वैसे अब door की भी testing करो. In no case should the test pressure be less than 6 meter head for sliding doors and no less than 3 meters for hinge doors. Pressure जो है minimum head, if that is becoming less by the above requirement, then in any case the minimum head has to be 6 meters of water and 3 meters of water for sliding and hinge doors respectively. The framework to which the door frame is secured for the purpose of testing at the works should not give greater reinforcement to the frame than the stiffening of the bulkhead to which it is fitted. Obviously, you are exerting these pressures ashore, testing it ashore. So you will be attaching the door to a certain structure. So that structure itself should not start imparting more strength to the door frame and the door than what the bulkhead on the ship would do. The test is to determine whether the door has sufficient strength and reasonably watertight under pressure. The rate of leakage and deflection of the door at the center should be recorded. Of course, that's not our job. It's the people who are testing it ashore. They will see how much is the leakage under that pressure head, how much is the deflection, and if they are within acceptable limits, the door passes the test. Otherwise, the door would be rejected. After a satisfactory hydraulic test, each watertight door and its frame should be stamped with the following identification mark. That should have the certifying authority name, tested to how many meters of head, date on which it is tested, and the surveyor's initial. So the door which has been tested would be stamped, duly stamped, so that people can know the standards to which it has been tested. After being fitted in place on the bulkhead at the ship, the door and the attachment of the door frame to the bulkhead should be included in the hose test requirement for the watertight bulkheads. Correct? Now, the other day somebody said कि हमारे यहाँ तो हमने सारे bulkheads का hose test किया था except number 3 जो कि हमारा ballast tank था. And we discussed there also that only the compartments which are designated to take water will be actually filled up with water for testing. Others would be tested through hose test. So once the watertight door is fitted on a bulkhead, and obviously that bulkhead is to be tested through hose test, then this arrangement also gets hose tested. All sliding watertight doors should be operated by hand, and if power operated by power in the presence of surveyor who should note and record the times taken to close the door. We saw that when you are operating individual door, from the time it starts moving, the minimum time it should take to close is 20 seconds, maximum time is 40 seconds. The door shall move at a approximately uniform speed. The surveyor should see that any warning signals are efficient and the indicators register properly. That means you have the indicator whether the door is closed or open, the bridge at SCC and at the local location. Plus warning signs are the audible and the visual signals. Where are the visual signals required? Visual signals are required in spaces where the noise level exceeds 85 decibels, if you remember, guys. Hinged watertight door is to be inspected and tried. The surveyor should see that the lever operated clips are in order and the joints are watertight. With this, we come to end of this particular part of our discussion, that is watertight doors. We can take a small break. What I'll do is I'll also send you these notes on watertight doors now. And then we have another small topic which is to be covered, which is linked to it. And then all your diagrams would be covered as far as chapter 4, question 4 is concerned. that is bow and stern doors. I need to do that, so we can take that up after the break. Let's take a 20 minutes break. We get together again at 12:50. Is that okay, beta?
Yes, sir.
Yes, sir.
So let's get together at 12:50 to close out on bow and stern doors so that this topic is completed and we thereafter take it up again. Okay. ठीक है बेटा. Let's take a small break.
Thank you, sir.
Okay. Okay, guys, can you give me some half an hour or so to finish off this beta, and then we can call it off?
Yes, sir.
Yes, sir.
Just give me half an hour or so. Anyway, I have also started working, just for your information, I have also started working on ROR. Give me your opinion on this. This is how I want to come out with ROR. Tell me, like, give me an honest opinion. Do you think this will be of any help? I'll just show you one part of it. I'll just show you one part of it. See this one. This is rule 1A, verbatim. Then what you need to know here is the meaning of vessel, all vessels. So there you see you have the explanation for the vessel out there. Then you have the high seas which you need. Then you have the explanation for high seas, which of course would come in the video form. I'm just trying to put the stuff together. And then you need basically navigable by seagoing vessels, and uska explanation comes here. So do you think this sort of presentation would be helpful in understanding the rules better?
Yes, sir.
मैं थोड़ा stability को
Yes, sir. Very much.
Yes, sir.
stability को थोड़ा hold पे डाल के I'll start launching this also. So maybe in a week, one video of ROR and one video of stability. That's how I'll probably plan going forward. So anyway, a lot of work is yet to be done. It's I've already spent about 2 days on it. Anyway, so this was just to have your input. So if you feel that it's going to be worth, then let me release the introduction at least tomorrow, and then we can start with the rules. Okay. Anyway. So where were we? We were in this part, bow and stern doors. Okay.
सर ये जो आपने अभी पढ़ाया था प्लीज उसके वो अपडेट कर देते ना।
क्या नोट्स चाहिए?
हाँ सर
मैं भेज दूंगा बेटा को. No, not to worry. No, not to worry. Okay guys, let me just put the headphone. Okay, this bow and stern door is also part watertight doors only, but only thing is they are being specially dealt with because they are special types of doors. So you see, we all know that bow doors and stern doors are all basically on ro-ro ships, right, for vessels to move in and out. Now the bow doors, guys, if you see the bow doors, they can be of any of the 3 types. They can be visor type, they can be side hinge type, or also called as barn door, or they could be side shifting type, sliding, जैसे आपका इको में slide करता है door side में. Okay, visor is better like the visor of the helmet, जो helmet का शीशा होता है उसकी तरह. So what is visor type? This is visor type. So is it clear? जो helmet की तरह शीशा ऊपर नीचे उठ जाता है, ये जो door है, this is the door said to be visor type, right बेटा? एक minute. Okay, then this one is side hinged or barn type. You can see this door hinged on the sides and opening this way. Or you could have side sliding type. On this you can see ये side में slide हो गए. These are side sliding type bow doors. So there can be 3 types of bow doors: visor type, side hinged, or side sliding. Now basically आपको ये diagram bow door की और bow ramp की आपको ये diagram आपको करनी है. ये 2 diagrams हैं. इनमें से दोनों डायग्राम अलग अलग उसकी हैं. एक बंद है वाइजर टाइप, एक में खुला हुआ है. सो लेट अस सी दीज डायग्राम्स. यू सी दिस इज द bow visor in the open position. You can see it in the open position. What is operating it are the hydraulic ramps. So this is the hydraulic ramp which is operating it. When you close it, it will come and close along this line. It will close like this. What is this? This is the ramp. So once you open the bow door, this ramp can be opened up, and obviously the ramp opens like this. You can see it here, deck, and the ramp will open like this. How is this visor connected to the body of the ship? It is connected through these 2 hinges out here. So I'm sure it is clear to you. This is the piston, hydraulic piston in the closed shut form. right? When you bring the visor down, the visor would basically come and close. Here is the visor in the closed form, closed shape out here. This is where the ramp opens up. So ye jo line hai, this is where the ramp opens up. So this ramp would open up along this line and opens like this. And here the connection of the visor to the main hull of the ship is through these hinges. It is operated through these hydraulic ramps. And this is diagram of a bow door and a ramp. बेटा ये भी क्वेश्चन नंबर 4 का पार्ट है. सो bow door and ramp का अगर डायग्राम आएगा, you can make this visor type diagram because sliding वाली मुश्किल होती है बनानी 3D में वो शो करना. Likewise hinge type also will not make much sense because they are like doors only. जैसे घरों में पहले 2 दरवाजे होते थे, so they are like 2 doors hinged on either side. Okay, this will be the easiest to make. It is the same diagram where now the ramp is this visor is closed. So I think if you get a question, I'll send you all these diagrams, but if you get a question, this is the diagram you should be eyeing to draw for a bow door. Right, beta? ठीक है भाई?
Yes, sir.
Okay.
यस सर. भैया
This is
नेक्स्ट
where
वाली नहीं बनानी है, ये वाली.
नहीं बेटा इतना टाइम नहीं होगा तुम्हारे पास, ये एक बना दोगे बहुत है. बिकॉज अगर बाव और स्टर्न आएगी तो दोनों बनानी पड़ेंगी, वैसे ही 2 हो जाएंगी. खाली बाव भी आएगी तो इसमें भी आपके 1 2 3 कम से कम 3 तो बनाओगे अगर ये पैकिंग छोड़ भी दोगे तो. सो 3 पीस तो ऑलरेडी हो गए और कितने बना पाओगे? आई डोंट थिंक यू विल बी एबल टू मेक मोर देन दैट इन ड्यूरिंग द एग्जाम. सो ये दूसरी मत बनाना रैम्प, क्योंकि इसमें क्या है ना, कम सी वो जो हिंजेस है वो यहाँ पर है इसके. ये तो बेसिकली यू विल नॉट, ये सॉरी माय मिस्टेक, hinges are here. Here are the hinges which were on this diagram here. ये वाले जो hinges थे ये इस डायग्राम में यहाँ पर आ गए और यहाँ से ये रैंप को पूरा, इसको वाइजर को पूरा उठा देगा. ये अंदर में हाइड्रोलिक वो पिस्टन्स हैं विद एक्चुएटर्स and you can see correlate the two diagrams. This is more for basically understanding this previous diagram, because if you can correlate it to this one, then it will be easier for you to draw this one in the exam logically. So एक ही बनानी है, पहले वाली बनाना है, इसमें कम पार्ट्स हैं, इसमें ज्यादा दिखाई नहीं देता है. बट अगर तुम्हें लगता है कि तुम्हें ये ज्यादा आसान है, टाइम बहुत सेव हो जाएगा, और if you're running against time, then make something at least. Don't leave it out completely. Now these are situated above the freeboard deck. Bow doors are situated above the freeboard deck of the vessel. Where the bow doors lead to a complete or long forward enclosed superstructure, they require an inner door to be fitted as that is part of the collision bulkhead. अगर ये बेटा bow door खुल गया और पीछे में आपका inner door काफी वो space लंबी है, तो obviously there will be another protection required above the collision bulkhead, and that shall be treated as part of the collision bulkhead. So there is another inner door required, and that is fitted as part of the collision bulkhead. This would also be in keeping with SOLAS requirements for passenger ships, where the collision bulkhead is to be extended weather tight to a deck next above the bulkhead deck. ये बेटा हमने requirement जब हमने collision bulkhead किया था, we did not do it then. Okay, it was intentionally left. I knew it will be covered here. कि in passenger ships, the collision bulkhead up to the freeboard deck is required to be watertight, of course, no doubt about it. But it has to be extended weather tight to another deck above it. But this extension of the collision bulkhead, it need not be fitted directly above the bulkhead. So that means at the bow of a passenger ship up to the freeboard deck, you are required to have the collision bulkhead watertight like any other cargo ship or any ship for that matter. In passenger ships, even above that, up to the next deck, you're required to have one more bulkhead which is weather tight, and that can be directly above the collision bulkhead, may not be directly above the collision bulkhead, but there has to be another bulkhead forward because collision bulkhead needs to be extended to the next deck in a weather tight, which has to be weather tight. So obviously that will be where the collision bulkhead is, and maybe slightly offset if the need arises. So that is what he's trying to say. Sloping, weather-tight vehicle ramp may be fitted in some ships to form the collision bulkhead. In some ships, when you close the ramp inwards itself may form the collision, may be treated as the collision bulkhead above the freeboard deck. So freeboard deck तक का तो collision bulkhead जैसे हमने पढ़ा था वैसा ही होगा. उसके ऊपर जो दूसरा weather tight ऊपर तक लेके जाना है, one more deck, उसमें either you can have another bulkhead or the ramp itself can be counted as a weather tight bulkhead. Sorry. This ramp may extend forward of the specified limit of the collision bulkhead above a height more than 2.3 meters above the bulkhead deck. What does it mean? That if you're saying that ramp is to be treated as the extension of the collision bulkhead as required by SOLAS for passenger ships, then as per SOLAS, the collision bulkhead also has the locational requirements. That means it cannot go forward of 5% of the length of the ship, which we studied in the previous topic. What is he saying? That if this ramp is to be treated as part of the collision bulkhead above the freeboard deck, then above a height of 2.3 meters above the freeboard deck or the bulkhead deck, the ramp may extend forward of that 5% length limit. That means जो collision bulkhead की locational limits थी कि collision bulkhead cannot be forward of this position. If you are using the ramp, some part of the ramp may go forward of it only if that breach is taking place at a height more than 2.3 meters above the bulkhead deck. Have you understood this point, beta, or should I need to explain anything on this one? इसको जरा पढ़ के एक बार समझ लो. Now we come to stern doors. उधर भी एक diagram करनी है हमने, and that will close the topic. Ro-ro vessels may be fitted with stern doors. These stern doors may open downwards. That means they may be hinged down or they may be hinged up. If hinged up होंगे तो ऊपर की तरफ खुलेगा और hinged down होंगे तो नीचे की तरफ खुलेगा. They may be hinged down or hinged up type. This is which type? This is obviously hinged down. In this, the hinges are down and this will open downwards. So this is the hinged down type. You may also have ships with stern doors with hinge up. Here is a case of a hinged up watertight door at the stern. Stern and bow door strengths are equivalent to the strength of the surrounding structure, and where they give access to enclosed superstructure, they are required to close weathertight. Ro-ro ships fitted with ramps usually have stern ramp, but some vessels fitted with bow doors may also have a bow ramp that doubles as the inner weathertight door, which we just discussed, and is lowered onto a link span when the bow visor or side hinge doors have been opened. Link span means, beta, when this ramp opens, it provides a link between the ship and the jetty. So it forms a link span. Ramps may be fitted internally to give access from deck to deck. In a ro-ro ship, you can have ramps fitted giving you access from one deck to another. These can be hydraulically or mechanically tilted to serve more than one deck and can be fixed in the horizontal position to serve as decks themselves. I think this somebody who's done ro-ro ships would be able to explain better. But yes, we can visualize little bit. But honestly speaking, if you ask me to elaborate more on it, because it was served on these ships, so I can only make literal sense out of this statement, beta. If anybody has served on ro-ros and wants to elaborate, you are more than welcome here. Is there anybody in the class who's sailed on ro-ros?
Yes, sir.
Beta, ये जो है ramps may also be fitted internally to give access from one deck to another. These can be hydraulically or mechanically tilted. So have you seen these adjustable ramps?
Yes, sir. Yes, sir.
So would you like to explain something about these?
सर इतने अच्छे से तो नहीं सर, वैसे नॉर्मली बता देता हूँ सर. वो
हाँ जो नहीं जो पता है हिंदी इंग्लिश में जैसे पता है बता दो.
हाँ जी सर, जैसे ये स्टर्न डोर होता है ना सर, जैसे हम ओपन करते हैं हम एक डेक पे पहुंचते हैं, वो डेक लेवल 6 होता है. अब उसके नीचे सर 6 से लेके 1 तक नीचे के डेक्स होते हैं और 6 से लेके 11 12 तक ऊपर की साइड होते हैं. तो सर जैसे 6 नंबर का जो डेक होता है वहां से आप 7 और 8 या डायरेक्ट 8 डेक पे जा सकते हो.
Okay.
वो रैम्प सर अंदर से उसमें ये हाइड्रोलिक लगा होता है, उसका
Okay.
उसको हाइड्रोलिकली ऑपरेट करते हैं। वो सिलेंडर पूरा डाउन होता है, जैसे सर बाहर का रैंप होता है ना सर, बाहर के रैंप
हाँ
में थोड़े बहुत हिंजेस होते हैं, वो 3
हाँ
फ्लैप से बना होता है बाहर का डोर,
करेक्ट
अंदर वाला एक ही फ्लैप से बना होता है। वो पूरा का
हाँ
पूरा ऊपर जाता है, पूरा का पूरा नीचे आता है। तो वो
ओके
6 से लेके उसके पैडिंग करी होती है नीचे, लाइक वो कहाँ बैठेगा, उसकी लोकेशन पूरी पॉइंट्स जो होते हैं वो वहां पे आके सिट हो जाता है, और वापसी के टाइम जब उसको उठाते हैं वो वैसे ही लिफ्ट अप होके सीधा ऊपर की साइड बंद हो जाता है। इंटरनली अंदर होते हैं, और सर 3-4 होते हैं वो ये हाइड्रोलिकली नहीं मैकेनिकल होते हैं। उसको वो किसी जैसे सर वो हिंजेस बनाई होते हैं, उसके ऊपर बैठे होते हैं। अगर आप उसकी जैसे थ्रेड को पुल करो तो वो बंद हो जाएगा, जैसे वो वेट के कारण बैठा हुआ है उसके ऊपर।
ओके ओके ओके
उसको
ठीक
सर
है
हाथ से जैसे सर हम उठाते हैं ना, वैसे
हाँ
उसमें वो ट्रक सा छोटा सा ट्रक लगा के वो उसको लिफ्ट अप करता है, लिफ्टेबल होता है वो।
हाँ
उसको लिफ्ट अप करते हैं, उसकी जिस बाउ सिटिंग जिस पॉइंट्स पे वो बैठा होता है
हाँ
उसको अंदर कर देते हैं। तो फिर वो एकदम से जैसे ग्रेविटी से नीचे आ जाएगा, उसको फिर थोड़ा थोड़ा वही सिलेंडर के साथ ही, ट्रक के साथ ही छोटे छोटे नीचे लेके आते हैं। फिर उसके जो हिंजेस होते हैं उसको बाहर निकालते हैं, उस पर बैठ जाता है वेट के कारण अपने।
हम्म।
ऐसे भी होता है सर।
ये जो एडजस्टेबल रैंप है, आई थिंक दिस इज समथिंग लाइक, तुमने कभी देखा होगा ना ये जो ट्रक्स पे बेटा, मेरे ख्याल से आई थिंक दे में भी समथिंग लाइक दिस, जो
हाँ
ये
जी
अपने
सर। सर जैसे
इलेक्ट्रिसिटी डिपार्टमेंट वाले हाई पोल्स के
हाँ
लिए उनको यूज करते हैं ना, एडजस्टेबल।
हाँ जी, हाँ जी सर, हाँ जी सर, वो भी वाले, हाँ जी वो
हाँ
भी होते हैं सर,
हाँ
वैसे
इट
भी।
इज, so that is what it is saying actually, adjustable ones are more like the ones which we have
तो
seen
जैसे
these PW।
पार्किंग करते हैं सर, कुछ होते हैं ना डबल पार्किंग होती है, एक नीचे भी हो जाती है, एक ऊपर पार्किंग भी होती है।
हाँ 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 हाँ
वो
ओके ओके
ऊपर वाले नीचे भी आ जाते हैं, वो पूरा बंद
राइट
भी हो जाता है, वैसे ही
राइट
सर।
राइट
उसको नीचे से
ओके।
ऊपर उठाने के लिए वेट नीचे लगाना पड़ता है, वो पुश करता है, वो अटक जाता है वहां जाके, ऐसे करके।
ओके व्हिच कंपनी आर यू सेलिंग विद बेटा?
सर आई वाज विद वॉलम, बट नाउ आई एम इन एंग्लोस्टन।
अच्छा एंग्लो, तो एंग्लो में भी क्या रोरो है एंग्लो में?
नहीं सर, आई डिड इन कैडेट शिप, दिस शिप, नाउ आई एम इन
अच्छा अच्छा
टैंकर।
हाँ, तो फिर तो भूल गए होगे यार, अब तक तो आधी चीज भूल
हाँ,
गए होगे।
यही याद है सर।
एंग्लो में सर रोरो नहीं है सर।
नहीं है ना रोरो, हाँ ठीक है।
रोरो नहीं।
दैट्स व्हाट आई वाज, हाँ no, when he said रोरो that's why I asked him बेटा।
नहीं सर, इन कैरियर शिप आई हैव डन वन शिप इन
ओके ओके
वॉलम, नाउ आई
ओके
एम इन
ओके
एंग्लो
ओके ओके गुड।
टैंकर्स में।
In some ships they can even be raised into hatch space and serve as weather tight covers. These ramps, basically ramps can be used as watertight doors, weather not watertight, weather tight doors or weather tight hatch covers, depending on the arrangement that may be there. So basically, what is this whole idea of the ramp acting as doubling up as either a weather tight door bulkhead or a weather tight hatch cover? The idea is to save space, कि उसका ड्यूअल पर्पज, कि खोल दिया तो इधर यूज हो गया, बंद कर दिया तो दूसरी तरफ का पर्पज इट सर्व्स अंडर सोलास, दैट्स द होल आइडिया। बेटा ये डायग्राम सबसे आसान है, दूसरी भी है क्या? नहीं, इसमें पहले वाली ही आसान है, ये देखो ये वाली स्टर्न डोर एंड रैम्प डोर की ये डायग्राम आप लोग, इट्स अ वेरी सिंपल स्ट्रेट डायग्राम। इट्स अ हिंज्ड अप, इट्स अ हिंज अप टाइप डोर। हियर इट इज इन द क्लोज्ड फॉर्म। इसको ओपन करोगे तो ये ऐसे खुल जाएगा। यहाँ पर हाइड्रोलिक सिक्योरिंग क्लीट्स हैं और यहाँ पर हाइड्रोलिक ओपनिंग रैम्स हैं। ये रैंप जब खुलेगा तो ये जो बंद वाला है ये खुल के दिस विल बी द ओपन पोजीशन, जो ब्रोकन लाइन से दिखाया हुआ है। एंड विद नाउ दिस इज वेयर द रैंप हैज कम डाउन नाउ। ये आपका स्टर्न रैंप है इन द क्लोज पोजीशन, और आपने इसको डाउन कर दिया तो ये अब आपका हो गया रैंप फॉर व्हीकल्स टू गो इन एंड आउट। सो ये आपका स्टर्न रैंप डाउन पोजीशन है, ये स्टर्न रैंप अप पोजीशन है, ये आपका स्टर्न डोर क्लोज्ड पोजीशन में है, ये आपका स्टर्न डोर ओपन पोजीशन में है। इट इज हिंज्ड हियर, you have a hydraulic piston out here, likewise you have a hydraulic piston here which will basically operate the your ramp. So ये आपका ये बेटा, now when the ramp is open you see this is acting as a link span between the ship and this structure out here, so that is what was meant by the link span there. So this is the most suitable diagram in my opinion for exam purposes for a stern door and ramp if it is asked for. बस इसके बाद ये MS हेराल्ड ऑफ फ्री एंटरप्राइज का जो एक्सीडेंट हुआ था उसके बाद कुछ चेंजेस आए थे, दैट आई विल सेंड टू यू, यू कैन गो थ्रू देम। इसमें कुछ ऐसा नई चीज है नहीं, सो दिस विल बी पार्ट ऑफ माय नोट्स, दिस विल रीच यू सो दैट यू कैन गो थ्रू। तो नाउ बेटा मैंने आपको बेसिकली नाउ जस्ट अ क्विक रिकैप, आपका जो क्वेश्चन नंबर 4 है ना 30 नंबर का आता है, उसकी आपकी जो पॉसिबल डायग्राम्स है, एक तो वाटर टाइट बल्क हेड, that is watertight bulkhead plate type, plain and corrugated. दूसरा उसके लिए बेटा आपका है ये क्या नाम है आपका watertight doors, hinge type, vertically sliding and horizontally sliding. ठीक है. तीसरा आपका है बाव डोर, एक नेक्स्ट बाव डोर छठा, और सातवां है आपका स्टर्न डोर. ये बेटे आपके 7 डायग्राम्स हैं which form question number 4. So question number 4 in phase 1 does not have unlimited scope. It has a very well defined scope, and in that very well defined scope I'm sure you will be able to do it. इसका बेस्ट ढंग यही है कि now since you know which are the 6-7 diagrams, जो नोट्स नहीं आए मैं आपको आज ही भेज देता हूँ. आप अपने कन्वीनियंस पे इनको बेटा हफ्ते में एक बार 2 डायग्राम हर हफ्ते ड्रॉ कर लो, and you will be comfortable with these diagrams because sketch needs to be neat, sketch needs to be labeled, or then only you will get good marks in question number 4. And please do not forget कि 30 number का question है. On a bad day also you must not eye anything less than maybe 20. कितनी भी गंदी डायग्राम कितनी भी जल्दी में बना लो, 20-22 नंबर से कम you should not be banking on it. और इसमें तो बेटा कुछ कैलकुलेशन भी नहीं सीखनी, डायग्राम प्रैक्टिस करनी है. तो those who may have be struggling with numerical, for them it makes all the more sense कि ये जो particular part है जिसमें आपको डायग्राम ड्रॉ करनी है, at least इसमें then you should be eyeing something like 25-26 marks. Those who may be good numerically may just say कि यार चलो 20-22 का काउंट करके we can bank on it, and that's how you need to plan your things. 30 में से 70% नंबर तो आने ही चाहिए, 20-21 तो आने चाहिए बेटा, otherwise you will be little tight. थ्योरी वगैरह पे ज्यादा दारोमदार हो जाएगा. सो द बेटर वुड बी आपको 120 नंबर का जो पार्ट ए है, 120 नंबर में 30 नंबर के तो 90 नंबर के न्यूमेरिकल्स हैं. 90 नंबर के न्यूमेरिकल में मैं आपको 20 नंबर की गलती का लीवे दे सकता हूँ. 70 नंबर आपके न्यूमेरिकल में आने चाहिए, 20 नंबर आपके क्वेश्चन नंबर 4 में आने चाहिए. You must be happily sitting with 90 marks out of part A on a bad day. On a good day, it could be 100 plus. On a bad day, 90 marks in part A. Then you need another 30 marks to cross the line out of 80 in part B. 80 में से आपको 30 चाहिए. That means now you can just attempt those 4 questions from there. उनमें भी बेटा 2 की थियोरी हो चुकी है, watertight door और watertight bulkhead की. बाकी थियोरी हम कर लेंगे. So you will be comfortable. आपको बेसिकली क्या करना है ना बेटा, आपको एक तो जो कई बार बच्चे गलती करते हैं वो ये करते हैं कि वो पार्ट बी को सोचते हैं इसके बिना हम पास हो जाएंगे, कुछ भी लिख देंगे. डोंट रिलाई ऑन दिस. डू एज गुड अ प्रिपरेशन इन पार्ट बी एज यू डू फॉर पार्ट ए. व्हाई? कि किसी दिन तुम्हारा पार्ट ए बिल्कुल ही खराब हो, तुम एक क्वेश्चन बिल्कुल ही कपूत कर दो, 30 नंबर 40 नंबर कट गए out of 90. if you are struggling at 55-60, don't give up because अगर तुम्हारे 70 भी क्रॉस हो जाते तो 50 नंबर you should be able to get from the theory. So you have to have the theory as a backup for a bad day in numericals. Otherwise numerical should basically be seeing you through and taking you close to the finish line. ठीक है बेटा, तो ये नोट्स मैं आपको भेज दूंगा. मेरी तरफ से बेटा आपके 2 टॉपिक हो गए हैं. नेक्स्ट वीक when we meet, we'll start with Simpson's rules. We'll meet on the board because the first part of it we'll have on the board before we do something else. And like dry docking and grounding, we'll be doing good 20 questions in the class. 20 क्लास क्वेश्चन क्लास में करेंगे. आप फटाफट अपना कैलकुलेटर वगैरह तैयार रखना, कैलकुलेट करेंगे. तो आपको ये कोई ज्यादा भार पढ़ने की जरूरत नहीं है. आप अपने ये 2 थियोरी के चैप्टर्स पे फोकस कर लो. एज फार एज नेवल आर्क इज कंसर्न, आई एम एज्यूमिंग कि आपकी जो ड्राई डॉकिंग है दैट इज इन अप योर स्लीव नाउ एंड यू आर वेरी कंफर्टेबल विद ड्राई डॉकिंग. एंड आई एम श्योर इवन सिम्पसन्स रूल्स will be easily comfortable. We'll do enough questions in the class, so you don't have to basically worry about the calculation part. We are giving so much of time in the class for numericals. We'll be able to gain confidence. सिर्फ मैं ये चाह रहा हूँ कि हम लोग लास्ट के 15 दिन ना जो बाकी के मिसलेनियस क्वेश्चन पास्ट पेपर्स हैं, जो कि तुम्हें मैं कहूंगा कि तुम पेपर देखो और लेके आओ डाउट्स. आई वांट टू कीप अबाउट 15 days फॉर दैट थिंग एट द एंड. ठीक है बेटा, चलो ठीक है बेटा. कैन आई साइन आउट नाउ इफ इट्स ओके विद यू?
Yes, sir.
Okay. Okay, guys, take care. See you next week then.
Yes.
Okay. Okay, beta. Bye.
Thank you.
मम्मी अभी दूध हुआ नहीं है, देख लेना। अभी नहीं हुआ है।
हेलो शिवान, क्या हाल है भाई?
माइक बंद करो भाई।
हाँ हाँ, और वो क्वेश्चन हो गया आपके हो गए ना? आपके वाले क्वेश्चन कर लिया आपने? हाँ, आप बोल नहीं रहे ना। मैंने यही सोचा कि कुछ तबीयत खराब लग रहा है। अच्छा अच्छा, आवाज़ सही लग रहा है। दवाई ववाई ले लो भाई। लेट कार में क्या है वो फालतू में बकरे करके चले जाएंगे। बस बाकी सब बढ़िया। यार तुमने वॉल्यूम से कैट हो तुम? मैं कह रहा हूँ वॉल्यूम में कैट सीख किया आपने? अरे फ्लीट में हो? मैं तो फ्लीट में हूँ भाई। मैं तो इसमें था यार अभी मैं 2018 सेलिंग नहीं की ना एक्चुअल में, कुछ फैमिली प्रॉब्लम थी। मैं इसमें था एक केमिकल चैलेंजर, केमिकल फील्ड में। अच्छा अच्छा, मैं 10 में हो गई। अच्छा, तो दिल्ली ऑफिस गए थे? हाँ। अच्छा 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 अच्छा, मैं तो केमिकल में लगा था। केमिकल चैलेंजर वाला सुना होगा आपने, ग्लोबल स्प्रेड हो जाती है। नहीं बना दिया सर, मेंटेन मेंटेन हो रही है। मैं गया नहीं ना एक्चुअली में, घर में थोड़ी प्रॉब्लम हो जाती है। नहीं मुझे तो बना रहे थे, मुझे सेकंड में भेज रहे थे, मगर उस टाइम पे मेरी सीयूसी का पंगा होगा इसलिए फ्रीजिंग करना पड़ रहा है। वो सी टाइम लैस हो रहा है इसमें तो उनकी वजह से मेरी सीयूसी इशू हुई 2 साल के लिए। उसके बाद वो अब जो अप्लाई कर रहा हूँ तो मुझे सी टाइम लैस आ रहा था, बोला फ्रीजिंग करना पड़ेगा, तो मैंने करना पड़ेगा। हाँ उसमें पड़ गया हूँ मेरा। मेरे 3 कॉन्ट्रैक्ट हुए हैं, 18 महीने 6 दिन हुआ है। ना जूनियर एक ही मारा था, वो भी थर्ड में काउंट हुआ ना मेरा। हाँ मुझे तो लास्ट सैलरी मिला था 35। तुम्हें ड्राइव नहीं मिला था? अच्छा 2700 है। मगर केमिकल से सही है, ड्राइव में सही है भाई, केमिकल में हेडेक बहुत है। हाँ हाँ, अरे इसको पता ही नहीं चलता भाई। आज यहाँ पे बिल्कुल ऐसा है ना, बाल्टी भर के यहाँ फेंको फिर टैग क्लीनिंग करो, पता चलता है हालत खराब हो जाती है। ड्राइव में थोड़ी सी सहूलियत में। हाँ ठीक है भाई, बेस्ट होगा। अरे ठीक है।